If you're building a data product and if you want to test your data pipeline, this video will walk you through how to do it using LocalStack and Specmatic. Let's consider an order cancellation data pipeline where we have messages from various sources being dumped to a Kafka topic called cancel order. A Lambda function picks up these XML messages and transforms them to JSON messages and pushes them to the process cancellation topic. The Lambda function could also potentially enrich the XML message by adding defaults for any missing values. The JSON message could then potentially go through a chain of Lambda functions and finally end up in something like Snowflake. So how do we test this data pipeline? One option is to start with an XML message, make it go through the entire data pipeline, and check if it reaches Snowflake. Now, while there is a time and a place for an end-to-end test like this, it comes with a few drawbacks. Firstly, if something goes wrong, it's very hard to pinpoint which Lambda function was responsible for it. Secondly, we need to deploy the entire data pipeline in order to run the end-to-end test. This leads to delayed feedback. And finally, it's really hard to test multiple Lambda functions in parallel with this approach. So the question is, can we test each Lambda function in isolation, as this would then give us precise feedback on each segment of the pipeline? So let's focus on one segment of the pipeline for now, which happens to be the first segment in this case. Now, as a first step, we can document this flow in an AsyncAPI specification. Let's take a quick look. So this is an AsyncAPI specification where they've defined the two topics, cancel order and process cancellation. We've also defined a cancel order operation which entails receiving messages on the cancel order topic and replying with a message on the process cancellation topic. So if you see, this exactly correlates with the behavior of the Lambda function in the segment of the data pipeline that we're currently focusing on. Below, we've also described the schemas for both the messages. So on the cancel order topic, we're going to receive an XML message whose schema is defined in this XSD file. And on the process cancellation topic, we're going to receive a JSON message whose schema is described here. So with this quick overview, let's get back to the presentation. So we've now documented the behavior of this Lambda function in an AsyncAPI specification. Now, how do we ensure that the Lambda function adheres to its AsyncAPI specification? This is where Specmatic comes in. Specmatic can leverage the AsyncAPI specification as an executable contract test. So in this case, Specmatic will generate XML messages and send them to the cancel order topic. These XML messages will be received by a Lambda function. One key thing to note here is that both the Lambda function and the Kafka topic are not hosted on AWS, but on LocalStack. LocalStack allows us to seamlessly mimic an AWS environment. Using LocalStack, we can test our Lambda functions locally without using any shared infrastructure and thus get very quick feedback. Coming back to a Lambda function, once it receives the XML message, and if all things go well, it will reply with a JSON message on the process cancellation topic. This JSON message will also be pulled in by Specmatic. Specmatic will perform two checks at this point. First, it will ensure if the schema of the JSON message matches what's defined in the AsyncAPI specification. Secondly, Specmatic will check if exactly one message is received for the XML message that it has generated. If either of these two conditions are not met, the contract test will fail. So this is how we can test a Lambda function in isolation and ensure that it adheres to its AsyncAPI specification. Let's see a quick code demo. So this is our Lambda function. It's quite simplistic. It receives an XML message from the cancel order topic and generates a JSON message and sends it to the process cancellation topic. Let's take a look at the contract test. Again, quite simplistic. All we are doing here is that we are setting the Kafka host in port and an examples directory from which Specmatic can pick up test data. So here's how an example looks like. So what we're saying here is that Specmatic will generate this XML message and send it to the cancel order topic. and it will expect this JSON message on the process cancellation topic. Now, one interesting thing to note is that both messages have a correlation ID header, and this is quite useful to tie up this message pair. Specmatic will check if the correlation ID received along with the JSON message matches the one that it has sent along with the XML message. Okay, so let's try and run the test. Great, our test is passed. Let's see what has happened. So over here we can see that Specmatic has published this XML message on the cancel order topic with this correlation ID, and it has received this expected JSON message on the process cancellation topic with the expected correlation ID. As the message received is valid and adheres to the AsyncAPI specification, the contract test has passed. Okay, now what if I modify the Lambda function so that it deviates from the specification? Let's take a look at the spec again. In this, we can see that in the schema for the JSON message, we have a field called status, and it takes two values, in progress and failed. So if the Lambda function generates a JSON message with status set as any value apart from these two values, ideally our contract test should fail. Let's try it out. So I'll go to my Lambda function code and set the status as pending. So this is an invalid status as per the AsyncAPI specification. With this, let's try and redeploy our Lambda function. Okay, our Lambda function has been redeployed successfully. Let's give it a few seconds. Let's rerun our contract test now. Okay, so our contract test has failed, as evident from this message, that we've received an invalid message on the process cancellation topic. We're expecting in progress and failed, but what we've received is pending. So our schema validation has failed the contract test, and this will help us ensure that our Lambda function is always in sync with its AsyncAPI specification. So we can similarly run contract tests for all Lambda functions in our data pipeline. These contract tests can be run locally or also as part of your CI build. These tests give us quick and effective feedback early in the development cycle. If you wish to learn more about Specmatic and how to run contract tests, please do check out other videos in this channel.